In this demo, we'll perform a scan while leveraging generative AI. Okay, to get started in my demo, I've opened my browser and I've navigated to nmap.org/download.html #Windows. I'm here because we want to install Nmap on Windows. So on this page, locate latest stable release self-installer, select the link, and in the downloads dialog that appears, just select save. And that will save the self-installer to your download directory or whatever your default directory is for your downloads with your browser. Okay, so now that's done. Now on the second tab, I've navigated to pypi.org/project/python-nmap. And we're here because we need to install the Python nmap library, and that'll help us use the nmap port scanner with our Python code. Now we install that with Python pip package manager by typing pip install python-nmap. So we don't need to download anything from this page specifically. Okay, so down on the taskbar, I'll select the Visual Studio Code icon to bring up Visual Studio Code. Okay, so I have a Python script named enhanced-nmap-scanning.py open. We'll look at this code shortly. But down in terminal, first, I want to highlight the fact that we need to install python-nmap, and to do that, we can just type pip install python-nmap. Now, I've already done this, so when I press enter and it runs, it's going to say that the requirement is already satisfied, and yes, it does. Okay, so Python nmap is definitely installed on this system. Now, the self-installer was in the downloads directory, so I'll just go down to the taskbar. I'll select Explorer, I'll go to my downloads directory, and there's the nmap self-installer. Now to install nmap, you simply run the executable. When the user account control dialog appears, select yes, and then just follow all the default settings. Don't change anything, just click next, next, install, and then once it's finished, nmap will be installed. We'll have the nmap Python module installed, and we'll be ready to start working with nmap in our Python code. Okay, so I'll just click next, next, finish, and done. You may need to restart Visual Studio Code if you have Visual Studio Code open. I don't have to because I've already installed both of these. If I type nmap right now, I get a response, and that tells me that nmap is definitely installed. Okay, so now let's look at this code. All right, so lines 2 through 4, I import the Python modules I need. There's a new one now, nmap. Then on line 7, I get the OpenAI API key from my environment variable. Line 10 is the function definition, and the function's name is active_recon_analysis. We've already been through these parameters in previous videos, so I won't go through those again. Okay, next, we initialize a new nmap object. I name it nm, that's on line 23, and I equate that to nmap.portscanner. So that initializes a new nmap object. Next on line 26, I actually perform the scan. I'm performing a scan here for open ports on the 192.168.100.0/24 subnet. And what we do is we pass the name of the hosts that we want to scan, and I'm just, again, specifying the subnet and the arguments, and the only argument I'm specifying here is --open, so that's going to scan for open ports. Next on line 28, I initialize an empty string for the output. Then from lines 31 down through 37, I'm essentially iterating through the scan results, and I'm selecting the hosts, the open ports, and their status. Next, on line 40, I specify an F string named recon_query. Now this is essentially the engineered prompt that's going to be passed to the AI model when I make the call to active_recon_analysis. And speaking of which, on line 45, that's exactly what we're doing. So I equate recon_analysis with the results from the call to active_recon_analysis, and I'm passing in recon_query. And again, that's the engineered prompt that we specified starting on line 40. Next, I generate the outputs for the enhanced scan report. And this report provides an overview of the scan, the query prompt, and the insights obtained from the scan analysis. I'm including the query prompt because I want to see exactly what was submitted to the AI model. And then I simply print out the insights. Okay, so now let's go down into terminal. First, I'll clear the terminal. And now I'll run enhanced-nmap-scanning.py by typing Python enhanced-nmap-scanning.py. And I'll use tab to autocomplete and press enter. This may take you a few seconds. I'm going to fast forward through this though. All right, let's explore this output. So there's the title, Enhanced Scan Report. And then the following is the recon query F string. Okay, so the F string starts with given the following network reconnaissance information, and then it lists all the reconnaissance information that was gathered using the nmap command, right? So that is what's going to be submitted to the AI model, along with the last sentence, please use this information to provide insights for the scan. Below that, I have insights from the enhanced scan, and it tells me that the host at 100.1 has several open ports that may indicate the presence of a web server as well as other services. In actuality, that's my router. The host at 100.129 has several open ports that indicate the presence of a Windows server, including RDP. The host at 100.134 has several open ports that may indicate the presence of a MySQL database server. So it was able to grab that kind of insight simply from the ports that are running on those individual hosts. All right, well, with that, we performed a scan leveraging generative AI. In this demo, we'll leverage generative AI for enumeration. Okay, to get started, I've opened Visual Studio Code, and I have a Python script named enhanced-nmap-enumeration.py open. Previously, I've performed a port scan on a private subnet. The scan showed me that there were several hosts that had open ports. Now, I'm going to go just a little bit deeper by enumerating so I can obtain more information about those hosts. And that's what I'm doing with my enhanced enumeration script. So let's explore the script. From lines 2 through 4, I import the modules that I need for this demo. Note that on line 4, I'm importing nmap. That's the Python-nmap library. And to install that, you just type pip install Python-nmap. Okay, then on line 7, I grab my OpenAI API key from my environment variable that I set up. Line 10 is the function definition for active_recon_analysis. This function is going to use the OpenAI.completion.create method to interact with the GPT model. I'm not going to go through these parameters. I've already done that in previous demos. Okay, now scrolling down on line 23, I initialize a new nmap object. On line 26, I'm performing an aggressive scan by calling nm.scan. So with the scan method, I pass the hosts, and in this case, it's just my private subnet 192.168.100.0/24 and the arguments -a. -a enables operating system and version detection. So that's what I mean. We want to go a little bit further from our basic port scanning to now where we are enumerating the operating system and version. -a also enables script scanning and traceroute. Okay, so then on line 28, I initialize an empty string to hold the output. Now lines 31 down through 41, I'm iterating through the scan results. I'm going to pull the host, the operating system, its name, how accurate the guess is, the open ports, and their status. That's recon_info. I'm going to pass that as part of my engineered prompt, and that occurs starting on line 44. So recon_query is essentially the engineered prompt. And on line 45 through 48, it says, given the following network reconnaissance information, and it includes all the reconnaissance info that I'm gathering with the nmap scan, please use this information to provide insights for each host identified in the scan, focusing on any identified operating systems and open ports, especially those running on port 80, 53, or 3306. Then on line 51, I'm equating recon_analysis with the results of the output from the call to the active_recon_analysis function. I'm passing the function, the recon_query, that's again the engineered prompt that I designed starting on line 44. Then starting on line 55 to the end of the file is a report which just provides an overview of the scan. I'm also including the query prompt because I want to see everything that was submitted to the GPT model. I also print the insights obtained from the scan analysis. So down in terminal, I'll type Python and the name enhanced-nmap-enumeration tab to autocomplete and press enter. This can take a couple of minutes because it has to scan through all of the devices on the 192.168.100 subnet. I'm going to fast forward through, but again, just keep in mind that this can take upwards of a couple of minutes. All right, the script has completed and the report has been printed to the terminal. I'm just going to scroll up to the very top of the report. And the reason why I want to include the query string is because I want to see exactly what was submitted, again, to the GPT model. What was submitted, the entire engineered prompt, starts at given the following network reconnaissance information. Then it includes recon info, which is all the information gathered by the reconnaissance performed using the nmap command. Then to complete the prompt, please use this information to provide insights for each host identified in the scan, specifically focusing on any identified operating systems and open ports, especially those running on port 80, 53, or 3306. Then the end of the query string notification. Okay, and then below we have some insights. It tells us that 192.168.100.1 is most likely running Microsoft Windows 11 21H2, FreeBSD, or some other operating system, and it has 4 open ports. Interestingly, that is my router, so it's dead wrong here. 100.128 does not have any identified operating system or open ports. It's well protected. Host 129 is most likely running Microsoft Windows 7, Windows Server 2008, or 2008 R2, Windows 8, or Windows 8.1 Update 1. It also has a number of open ports. The fact that it's running such an old Windows operating system, the version information tells us that there may be some significant vulnerabilities there. Okay, so continuing on, and it tells us that 100.134 is most likely running Microsoft Windows 10 1607, and 100.2 is most likely running VMware Player, Virtual NAT device, and so on. We were able to take the reconnaissance information that we had based on the nmap scan, and we were able to analyze that using generative AI.